Our lesson for today will be looking at chemistry 1502. The topic for today, we still continue with alkyne reaction. The reaction will be looking at its acetylide ions. Lesson 1, 6, let us start. Alkylide ions or acetylide ions are formed from alkynes, but we have to understand that the type of alkyne that we will be using in this particular synthesis, it deals mainly with the terminal alkyne. We know that we have different types of alkynes. We have terminal and internal, and then internal, we know that we have two different types of internals, which is symmetrical and isommetrical. So in this case, we'll be looking at terminal alkynes, whereby the triple bond is between the first carbon and the second carbon, or we can say the triple bond is between the sp hybridized carbons. Before we start with the core synthesis of this lesson, let us understand something. We should understand that terminal alkynes are much more acidic than other hydrocarbons. So we have an acidic compound when we have a terminal alkyne. And you should know that a removal of an acetylenic proton forms an alkynide ion. It's a new term, which is acetylenic proton. And you should understand what is also an alkynide ion. When you talk about an acetylenic proton, we are talking about this hydrogen here. If we remove this hydrogen, we are going to form an alkynide ion. Remember that when you talk about ions, you're talking about those compounds or elements which their charge is not neutral, but we should have a positive or a negative. And we know that if we continue drawing other groups, we are going to have different types of carbons with their hydrogens, but the acetylenic proton, it is specifically this hydrogen which it is bonded to the sp hybridized carbon, or the first carbon, so that it makes one of the properties of this structure to be a terminal alkyne. The removal of this hydrogen will yield a carb anion, which is an opposite of a carbocation ion, which will be in this form. Remember that a carbocation ion, it's like this, with 3 bonds. So since we say this is acidic, in order to remove this proton, we will need a very strong base. The most common strong base is sodium amide. It's NH2. So if we remove this, we are going to have an alkynide like this. So this is no longer an alkyne, but it's an alkynide ion. So let us look at the reaction. Let us start with the general reaction. So we have an alkyne being reacted with sodium amide, but you should understand this. We know that sodium is a metal. It has a positive charge, and then we have an amide ion with a negative charge. So these will form ions, and then we know very well that hydrogen will be extracted by this amide, then this two electrons will actually be responsible in the formation of the alkynide ion. Then this hydrogen will join this. So it means that on the product we are going to have, let us just write it like this. We have sodium, and if this hydrogen joins this one, we are going to have an H3, which is ammonia. Then you can see that here we have an alkynate ion. Looking at a simple example, we can see that this is a terminal alkyne. The acidic proton is this one. So we are going to react this with our base to form alkynate ion Na plus NH3. So here is a quick question. You can pause the video and work it out. Play the video to verify the answer. Suppose we have this. We react this with our base. What would be the answer? The answer would be there's no reaction in this case. The reason why? This is not a terminal alkyne. And before we can continue, I want you to understand this. Looking at this, you can see that we actually consider this as one product. This is the second product. As you can see, there's no plus minus in between. But what is important is to form this, the alkynate ion. But the whole product, we call it sodium alkynate ion when we include this. Then one thing you should understand is that, remember in SN2 or SN1, we have nucleophiles. And specifically in SN2, we said strong nucleophiles, we see them with a negative charge. So in this case, we can consider this as a nucleophile. Should it happen that we react this with a substrate, we are going to get a reaction, which will be SN2. Let us stretch our synthesis. Now we know how we form alkynate ions. Let us look at how we can use them in an SN2 nucleophilic substitution reaction to form another compound. And if you can check from lesson 101 of alkynes reaction, we were reacting alkynes with other substances to form different types of functional groups. From alkynes to alkanes, from alkynes to alkenes, from alkynes to aldehydes, to ketones, to enols. So in this reaction, let us see what kind of a functional group are we going to yield. Suppose we have this terminal alkyne. We react this with our strong base. We know that what will happen is that we are going to remove the proton. We'll be left with an alkynate ion plus ammonia. Then we take this we react this with a substrate. Let's say we react this with methyl iodide. So you can see that this cannot be the substrate. The reason why? Because of this negative. So it's definitely a nucleophile, and then this will be our substrate. And remember that methyl halides, they work best with SN2. So the nucleophile will attack the electrophile, and then the leaving group will leave. And then we are going to form this is where we are going to yield our new functional, actually let me not say functional group, let me say our new compound. Plus this sodium, it is negative, this iodine, it actually going to be an iodide ion, will be negative, and then when they bond they'll form sodium iodide. Now let us look at this. Is this a new functional group? Let us write it in a manner in which we are going to see this. So we have CH3, CH2, C, triple bond C, then we have CH3. You can see that we still have an alkyne, but we have added a new carbon with its hydrogen. So we have extended this alkyne, and you can see that it's no longer a terminal alkyne, but it's an internal alkyne plus sodium iodide. So you can see that this lesson, this is where we add to the structure of the terminal alkyne. Because if you can see, this was butyl. We have 1, 2, 3, 4. Then hydrogen was here. So it was butyl, or 1 butyl. Now looking at this, we have 1, 2, 3, 4, 5. It is 2 butyl. Let us look at a few examples for the sake of practice. So the question is, write down the major product, or the product of the following reactions. We react this with our strong base. We can go ahead and pause the video, work it out, and play the video. Now we can see that this is the proton, or we can say it's this one. So it doesn't really matter which one we consider as our first carbon having the acetylenic proton. So we have our base here. So the product will definitely be with our alkynide ion plus NH3. Our second one plus so we have to understand that we are not talking about the SN2 reaction here. We don't have the substrate and the leaving group. We're just reacting. This is an acid-base reaction, by the way. So here we are going to have our lithium will be positive, and then this one will be negative. So we are going to have our alkynide ion here and lithium plus this hydrogen will join this hydrogens. We are going to have CH4. Number 4, And by the way, this is also a strong base. It is strong enough to extract our proton, our acidic proton. So number 4, the very same alkyne, in this case we do not have any reaction. The reason why, remember that I said we need a strong base, so this is not one of the strong bases we have. Let us look at another example. Sodium hydroxide, we know that we're going to have a positive and a negative. In this case, we still have no reaction. Reason being, it's a weak, actually it is not strong enough. Let me not say it is a weak. We're talking about the OH. It is not strong enough to extract our proton. Let us look at our last example. Plus NH3. So I hope you've learned how to form alkyne ions. In the next lesson video, which will be the continuous of this one, we'll be looking at the formation of alkylation of alkyne ions. That is when we talk mostly about how to add the chain of the alkyne. In this lesson, we've just looked at it, but not in detail. In the next lesson video, that is what we are going to do. That's it for this lesson video. This is Wahula SJ. Thank you very much.